Chapter 4.6 is where we're going to talk about graphing the other trig functions. So we talked about sine and cosine graphs, and today we're going to be talking about the reciprocals of those, so the cosecant and the secant graphs. Now remember, when we have a 0 in the denominator, that's going to give us an undefined part of the function, so we're going to have vertical asymptotes here. So again, as a reminder, cosecant is 1 over sine. So anytime that sine is equal to 0, you're going to have a vertical asymptote. And when we have a secant function, which is 1 over cosine, anytime that the cosine is 0, we're going to have a vertical asymptote. And because our sine and cosine functions are periodic, that means there's going to be multiple asymptotes. So as you're just saying, when cosine is equal to 0, and we know cosine is 0 at pi over 2, or multiples of pi over 2. So 1 pi over 2, 3 pi over 2, 5 pi over 2, and so on, we're always going to have a vertical asymptote at that value. And then when sine is 0, which you multiples of pi, 0, 1 pi, 2 pi, 3 pi, 4 pi, and so on, your sine value is 0, so you're going to have a vertical asymptote there as well. So this graph right here, we have the basic cosecant graph and the basic secant graph. And you can see with the cosecant graph that the corresponding sine function is graphed as well. And a couple things I want to note about that, and we're going to review them again when we go and actually graph these, is that whenever this sine graph crossed our midline, in this case the x-axis, whenever we cross that midline, we have these asymptotes. And then whenever we have a minimum or maximum on the sine graph, we have a minimum or maximum of a parabola. So you see right here, we have a minimum of that sine graph, and we have a parabola open downwards away from the midline. Right here, we had a maximum of the sine of the corresponding sine graph, and we had another parabola going away from the midline. Here was a minimum, and we have a parabola going away from the midline. And the same thing is true with the secant graph. So here's our secant graph, and the corresponding cosine function is right here. And anytime we cross that midline, again, we have a vertical asymptote. And whenever there was a minimum or maximum of that sine graph, we had parabolas graphed away from the midline. So being able to graph the sine and cosine functions is going to become crucial for this as well. So if you didn't understand that completely when we talked about it, this will be good practice for us to get them down pat. So here's just the general characteristics. Our domain, again, is going to be all real numbers except when we have those vertical asymptotes. We still have range, we still have period, and so on. Notice the range, though. There's nothing between -1 and 1. Because you remember, this gray line here, that's not part of the cosecant graph. We just use the corresponding sine graph to help us graph cosecant. So our actual graph is what I outlined in pink, and the y values never get below +1 or above -1. And the same is true about the secant graphs. So on this page, we're going to talk about how to graph them. So first thing we're going to do is we're going to switch it to the corresponding reciprocal function, either sine if it's cosecant or cosine if it's secant. And then we're going to graph that corresponding sine or cosine graph with dotted lines. And then again, whenever our sine and cosine graph crosses the midline, we have a vertical asymptote. And then when we have a min or max, we're going to sketch parabolas between and away from the dotted curve, or which is the midline of our corresponding sine and cosine graph. So if we look at this example 1 right here, we have negative secant of pi x. So we're going to change this to negative cosine of pi x. And we're going to graph that the same way we did yesterday, where we have interval, amplitude, period, axis, and all that stuff. And we have the table as well, just to help us. So our b value is pi. So we have 2 pi over pi as our period. So our period is 2. Our amplitude is 1. Our axis is y equals 0 because we didn't move up or down at all. We don't have a plus or minus on the outside. And then our interval will be pi over 2 times 1 over b, which is pi. So we get 1/2. So our interval is 1/2. So 0, 1/2, 2/2, which is 1, 3/2, and then 4/2, which is 2. And then the y value, so it's negative cosine. So we start at the negative amplitude, so negative 1. Negative 1, 0, 1, 0, negative 1. So I'm going to go back up here, and each of my tick marks I'm going to, like how I did for cosine and sine, every 2 grid marks I'm going to make a tick mark, and that's going to be my interval. And we also are going to go backwards, negative 1/2, and so on. All right, so let's put negative 1 right here and positive 1 right here. So when we do our dots, it's going to be 0, negative 1. Then we go up, down, down, down. And then this side will go the same way, follow the same pattern. And I'm just going to use a dotted line to draw this. You might say at some point, do we need to do the dotted line because you're figuring things out in your head? No, you may get to the point you don't have to, but that's just the way that makes sense to me. So anytime we cross the midline, we have a vertical asymptote. We cross the midline right here. We cross the midline right here. We cross the midline right here. Cross the midline right here. So those would be our asymptotes. Now, anytime we have a minimum or maximum, okay, so we have a minimum here, we're going to draw a parabola away from the midline. Here's a maximum, we're going to draw a parabola away from the midline. Here's a minimum, draw it away from the midline. Maximum, draw it away from the midline. Here, draw it away from the midline. Now, I can see how this is confusing with all the dotted lines and asymptotes. That's what I'm saying. At some point, you may not need to draw in the dotted cosine or sine curve. But for the first 2, I'm going to do that just so you can see how that works. But this is what the graph would look like. You don't need to erase anything. You can leave it just like this. All right, now letter B, 1/4 cosecant of x plus pi over 4. So this is really going to be 1/4 sine x plus pi over 4. So that pi over 4, these are going to go right pi over 4. So not right, left, opposite of what we see. So it's going to be left pi over 4. So now we'll do our amplitude is going to be 1/4. Our period 2 pi over b. Our b value is 1. We don't have a number in front of the x at all. So 2 pi over 1, which is 2 pi. Our interval is going to be pi over 2 times 1 over 1. So pi over 2 is going to be our interval. Now we are shifted, on our axis y equals 0. We don't have a plus or minus anything. We are shifted to the left pi over 4. So for our table, we're going to start at negative pi over 4, and then we're going to add pi over 2 each time. Now pi over 2 is equal to 2 pi over 4, so we're going to add that each time. So negative pi over 4 plus 2 pi over 4 gives you positive 1 pi over 4. Then we have positive 3 pi over 4, 5 pi over 4, and 7 pi over 4. So now on my graph, again, I want each of my scales, like I want two grids to be what my scale goes up by. So for this one, I'm actually going to start right here and say this is negative pi over 4, and then every 2, so this is positive pi over 4, this would be 3 pi over 4, and we don't need to write down what all of these are going to be. And then what I want to do for the y is instead of doing 1/4, because that would be very, very small right here, what I'm going to do is put 1/4 up here. Stretch things out a little bit. So that'd be negative 1/4. So yeah, drawing the scale also makes these a little bit confusing. So negative pi over 4, our y value, since this is a positive sign value, we start at the midline, then we go up to 1/4, down to the midline, down to negative 1/4, and then back up to the midline. So for our key points, go here, then here, then here, then here, there. And then we follow the pattern going to the negative side. And then this would be our sine curve that goes with this cosecant function. And again, anytime we cross the midline, which is y equals 0, we have a vertical asymptote. So we're going to have all these asymptotes here. And then I'm going to use light blue. And anytime we have a minimum or maximum, I'm going to put a dot there and draw a parabola going away from the midline. Now just make sure your parabolas don't touch your asymptotes. That's my only word of caution. We don't need to find out exact points of those parabolas, just where the vertex is and then the correct direction. So again, knowing how to graph these sine and cosine functions is going to be critical to graphing these. All right, now the next page has these last two problems, and like I said, I'm not going to draw the dotted lines, but we're still going to do everything else the same. And you may look at that and say, hey, this is much easier for me to see now without the dotted lines there. And so this might actually be more helpful. So we have negative cosecant of pi x over 2. So this is going to be negative sine of pi x over 2. So that's what we're going to be working with here. So our amplitude is 1. Our axis or our midline is y equals 0. Our period, 2 pi over b. b is pi over 2. So our period is 2 pi over 2. So 2 pi times 2 over pi. You're multiplying by that reciprocal, which is going to give us 4. So our period is 4. Now, you could say for our interval that it's going to be our period divided by 4. It's always divided by 4, and you get 1. Or you could do the pi over 2 times, well, 1 over b, pi over 2, which is going to be pi over 2 times the reciprocal 2 over pi, and the pi's and 2's will cancel, and we just get 1. So in some instances, it's probably easier to, like in here, it was probably easier to take our period, which is 4, divide that by 4, and get our interval of 1. Whereas some of the ones that we were doing earlier, when we had a period of like, 3 pi over 2, well, dividing that by 4 might be a little bit more difficult. We don't have any horizontal shifting here because we don't have a plus or minus inside the parentheses. So we're going to start at 0, and then we're going to go up by 1 each time. And this is a cosecant, which goes with sine. So then for our y values, we start at the midline. But then since this is a negative cosecant, a negative sine function, we go down to the negative amplitude, up to the midline, up to positive 1, and then back down to the midline. So let's go up here, and I'm going to mark off my intervals here, going up by 1s. So this will be negative 1. And then in the y direction, also going to go up by 1s. So we start at 0, 0, and then we go down because, again, we have negative sign. Up, up, down. And then follow the pattern. And now, anytime we cross that midline, I'm going to draw a vertical asymptote. Our midline so far for these 3 problems has always been the x-axis, so that makes this pretty easy. So there's our midline. And we're going to do asymptotes through all the midlines. And then anytime we have a minimum, draw our parabola, open downwards, a maximum, parabola opened upwards. So here I'm drawing it without that dotted sine curve. So this may look a little bit neater to you, and it may make more sense. All right, now letter D. Letter D has a shift down 2, because this is what is you're taking the secant of. These are not together, or you would see parentheses like that. So we're going to be shifted down 2, and since this is secant, it's really going to be the cosine of pi x minus 2. So our amplitude is 1. Our midline, our axis, is y equals 2. And then our period, 2 pi over b. Our b value is pi, so our period is 2. And then for our interval, you could do 2 divided by 4, which is 1/2, or do pi over 2 times 1 over b, which is pi. Pi over 2 times 1 over pi, the pi's cancel, and you get 1/2. Right, so we are not shifted left or right anything, so we're going to start the x values at 0 and then go up by 1/2, 3/2, and then 2. Now, because we are shifted down 2, so the axis should actually be y equals negative 2. We talked about the other day how we could just write in the normal y values and then either just count, know that we're going to go down by 2, or make a third row. Whatever works best for you is fine with me. So I like to just write the normal y values without the shift down. So let's do that first. So this is a cosine graph, so we start at the negative amplitude. So we're going to start at, it's positive cosines. We're going to start at the positive amplitude. So 1, 0, -1, 0, and 1. And then know that we have to go down by 2. So -1, -2, -3, -2, -1, and ignore that. So now I'm going to plot these points, 0, -1. Well, first, let's do our scale, our grid lines. So we're going to go up by 1/2. So every 2 marks is 1/2. So for the y values, I'm actually just going to go with what's written here, 1 and -1. And the reason for that is because we are shifted down 2 units, things might get a little bit off the grid if I go by anything else. So we have our values at 0, -1. Then we go down to the midline. Then we go below the midline, the negative amplitude, down and then up. And then we follow the same pattern on this side. And again, our midline, though, is right here. Okay, so that means our asymptotes, let's use purple. This is going to be an asymptote. This is going to be an asymptote. This is an asymptote. And this is an asymptote. And then any time between that, okay, so then look at that parabola. We're crossing the x-axis, and that's okay. We can cross the x-axis. Normally we don't, but because, again, we are shifted down to, we are ending up crossing that x-axis. Okay, then this one is below the midline, so it goes down. This one's above the midline, so it goes up. Below the midline goes down. Above the midline goes up. If you want to, you can draw in that midline if you want. But I'm trying to put fewer things on my graph to make it less confusing for you. But I'm not going to be upset if you end up doing that. So again, these I know that these are confusing because there's a lot going on. So just, again, remember, go back to sine and cosine graphs and start there, and then we can add in the asymptotes and then these parabolas. All right, so that's it for the video. Thanks for watching. Make sure to like it and subscribe.